Assalamualaikum and hi. Okay, so in this video, we will look at applications of integration in cost, revenue, and profit. Okay, so until now, let's recall a few things that we have learned. All right, so for example, we usually we denote the cost function. We denote the cost function using C, capital C for cost function. Okay, and then for revenue we use R, and then for profit we use P. Okay, that's what we have learned so far. And also, since we are done with differentiation, we can also find marginal, right? Marginal cost, marginal revenue, or maybe marginal profit. Okay, so from the cost function, we can if we differentiate, we will get marginal cost. Okay, the same for revenue and profit. If we differentiate revenue, we will get revenue prime, or its marginal revenue. Or maybe if we differentiate profit, the profit function PQ, we will get P prime. P prime denotes marginal profit. Okay, so that's why I write this only one time. Okay, because whenever you differentiate a function, you will get C prime or R prime or P prime. Okay, whenever we have prime, that means it's marginal cost, or marginal profit, or marginal revenue. Okay, and then we also have learned if we have cost function to find average cost. That means whatever we have here, divide by Q. So automatically we will get average cost. Okay, so let me write here once again. So this is marginal cost. Okay, this one is average cost. Okay, well, I think it's quite straightforward. Since we divide with Q, then it's average. Okay, whenever we have prime, it's marginal. Okay, what else? Marginal. Okay, before I forget. Okay, so how do you denote average cost? This is the same as C. Okay, you can write average cost with this notation. The function cost with the bar on top. So this means average. Okay, so if you are going to find average revenue, then the function R divided by Q. So that means average revenue is denoted by this notation. Average profit is denoted by this notation. Okay, with the bar sign. Right. Okay, so now in this chapter, since we are dealing with integration, that means to find, let's say you have, in the beginning, you have C prime. Okay, how can you go back to the original function C? Okay, the thing is, To find C, to go to the other side, to go backward, that means the operation must be integration. That means when you integrate C prime, you will get the cost function. Okay? So whenever you integrate marginal function, you will get the original function. Okay, let me rewrite this, the one here on the marginal cost integrate cost function. Okay, this means um, C prime. Okay, if we integrate, we will get CQ. Okay, from marginal cost, when we integrate, we will get the cost function. Okay, what about this marginal average? Marginal average. Okay, when we integrate marginal average is this. To find marginal average, you will find the average first and then differentiate. Okay, when you integrate, you will get the average cost. Okay, when we integrate, we will get the average cost. Okay, and then marginal revenue. Marginal revenue, the third one, marginal revenue is denoted by R prime. R prime Q. When we integrate R prime, we will get the original revenue function. Okay, the same for here. This is um, average revenue and then marginal. When we integrate this, we will get the average revenue function. Okay, the same for this. I mean, if you can understand the first one, you should be able to understand for, I mean, if you're able to understand for cost, you should be able to understand for revenue and also profit. Okay, because the concept are similar. Okay, we have this in this table. Okay, let's do this exercise question. Okay, suppose the marginal cost to produce product A is given by, okay, you are given with a marginal cost function. I hope you can see there's C prime here. Okay, very, very small. Okay, and the fixed cost for the production is RM 9,000 ringgit. Okay, where X is quantity. In this case, the variable is X. Well, it depends on the question. Okay, if the question uses X, so be it. Okay, find the cost function. Okay, to find the cost function, um, the cost function is denoted by Cx. Okay, but in the question, you are given with C prime. Okay, so in order to find Cx, you will integrate the given function because when you integrate C prime, you will get the original cost function. Okay, so let's integrate x squared minus 20x plus 100 dx. Okay, so this is the same as, okay, let's integrate. Integrate x squared, we will get x cubed over 3. Integrate 20x, we will get 20x squared over 2. And the last term, 100x. Okay, and then don't forget, no, we do not have the, this time we do not have the upper and lower limit. Okay, so okay, and as you can see, this is indefinite integral because we do not have the lower limit and the upper limit, right? So this should have plus C. Okay, however, this C denotes the constant for any indefinite integral, right? So basically, this is your cost function. Okay, this is your cost function. Okay, and also you must recall from what you have learned in the earlier chapters. All of this, the one with the x, um, the whole thing is the variable cost, and then C is the constant. That means this is the fixed cost. Okay, and I hope you notice that you are given with the fixed cost in the question. So actually we can write C of x equals to x cubed over 3 minus 20x squared over 2, or maybe we can simplify this. Let me erase this first. This is actually 10x squared, right? This is 10x squared plus 100x plus 9,000 because it's fixed cost. Okay? Because the constant denotes the fixed cost. Okay, so this is the answer for this question. All right. Okay. So that's the end for this subtopic. But I really hope that you will find more questions in the exercise section. Okay, so that you can work on not only the cost function but also the revenue and profit, if there's any questions on that. All right. I think that's all for this video. Thank you so much.